Hey, in this lesson, I want you to reason abstractly to use trig identities to find trig values, and I want you to use trig identities to simplify expressions. Here are some basic trig identities. We have our quotient identities, which is, you can say tangent is sine over cosine, and cotangent is cosine over sine. You can't divide by 0. We have the reciprocal, which we should know that sine is the reciprocal of cosecant, secant is the reciprocal of cosine, and so on. We have our Pythagorean identities. Cosine squared plus sine squared equals 1. Tangent squared plus 1 equals secant squared, and cotangent squared plus 1 equals cosecant squared. They're called the Pythagorean identities because they come straight from the Pythagorean theorem. If we think of the Pythagorean theorem as x squared plus y squared equals r squared. Well, let's take and let's divide both sides by r squared. So we get x squared over r squared plus y squared over r squared equals r squared over r squared. I was going to divide everything by r squared. And the radius can't be 0, so I'm not dividing by 0. Well, looking at our definition of cosine is x over r. So x over r is cosine squared of my angle. Y squared over r squared is sine squared of our angle, and r squared divided by r squared is 1. That's where that Pythagorean identity comes from. Now the others come from if I take x squared plus y squared divided by r squared. If I divide everything by x squared, I'll get cotangent squared plus 1 equals cosecant squared theta. If I divide everything by y squared, by x squared I should say, I'll get tangent squared plus 1 equals secant squared theta. We have our cofunction identities, which we know that cosine is the cofunction of sine. That is, it's just a phase shift of pi over 2. And then we have our even and odd functions with sine, cosine, and tangent.